各位好，我是普威科技 Edward。今天很高兴，我们欢迎到这个 M+p International 的国际部经理Mr. Kostian Bune 来台湾。然后呢，今天我们有一些震动相关的 Q&A， 然后我们会来请教一下Mr. Bune。Kostian, welcome.
Yeah, hello everyone.
Yeah. Okay. We know you are very familiar and has some experience on the model analysis and model testing. And also the M+p International has the solution is very good for the model testing. And so today we have some question we want to answer we call the frequency X question about the model analysis. So are you ready?
Yes, I'm ready to answer.
OK, 好。我今天有一个看板哈，我们就一一来跟各位做个询问。来，第一题。Okay, the first question: What is the model analysis?
Okay, so let me explain this question. What is modal analysis or vibration modes in general? So we face vibration modes of all kinds of, let's say generally speaking, vibrations in our daily life. So you will have vibrations in vehicles such as cars or motorbikes or scooters.
Yes.
There are many here in Taiwan. And we also see that this vibration in hand tools, in white goods, in machinery. So it's in our daily life. And these vibrations can be self-excited by the machine or the tool itself, or it can be excited externally from outside, let's say by wind excitation. So if you imagine on a large tower like the Taipei 501 tower, which is then bending, or if you imagine bridges, for example, So here we all see vibrations, and of course the best thing is that the vibrations have a very low amplitude. Best is of course no amplitude, because vibrations can really destroy machines or tools when it really vibrates large, and it can also have unpleasant feeling and disturbing the human body. So it's on your feeling in a car, for example, or when you use a machine or a tool, it vibrates and doesn't feel comfortable.
Yes, thank you. Now we are going to the next second. So, why the model analysis matters?
It's a good question. So, vibration modes are determined by structural testing, and there's a technology, so-called experimental modal analysis, abbreviated EMA.
EMA, yes.
Experimental modal analysis. And the target of the EMA is to find the natural frequency of a machine or a structure, to find the damping.
Damping.
That's what's in the structure, and to create and determine the mode shapes. So how is the thing vibrating? So natural frequency, damping, and mode shape. So that's the goal. That's the target of experimental modal analysis, and the structure usually is mounted and vibrating in a free boundary condition, so it can really move in all directions. So this is how it is performed. In this scenario, the damping is of greatest interest, because damping will go in mathematical models like computer-aided engineering (CAE) or finite element models (FE), because these simulation models don't know the damping. The damping is provided by EMA, and therefore EMA provides the damping on really real measurements and gives this to the models.
Thank you. And third, do you have any real application?
So real world applications, so there are really many of them, and I mentioned already bridges, so when you remember the Tacoma narrow bridge in the US is a very popular example.
Very famous example.
Yeah, so this bridge really broke down in the year when it was erected.
Yeah.
So that was November 1940. So it was bending and twisting, and then it was completely destroyed. And also some years ago, I remember the Millennium Bridge in London. This was 2000, and when they opened the bridge, so pedestrians were going over the bridge, there were some lateral movements, horizontal movements, unwanted movements. So the bridge was stopped, and then they created some dampers, absorbers, to minimize the horizontal effect of movements. So that's one example. Another examples are aeroplanes. So it doesn't matter if it's a military aeroplane or a commercial aeroplane. Aeroplanes are certified by experimental modal analysis in flight also. Yeah, so no aeroplane will fly without this certification, and then the data are given to CAE or FE models. And I give you a last one, tool machineries, which are important to have a great accuracy on the working piece for drilling or milling. So the accuracy is in micrometers, maybe also in nanometers, but this has to be very precise. And EMA is a tool to give good results on accuracy. So what to change, what to make better in tool machineries.
Yeah, I think there is another lot of example, but we have the time limit, so thank you. And fourth, yes, we know the computer science is getting better and better. So some people will say, oh, I can use the CAE, computer aided engineer. So can you use the CAE instead of the EMA?
To be honest, at the moment, not.
No.
So it's not the case. So let's say we still need EMA, experimental modal analysis, because that's the truth, and then we give values to the CAE or FE model. And I also tell you why, because CAE and FE models are today not so far that they accurately can determine real life conditions. So they don't give precise results. If this is the case in future, then we can eliminate EMA. We don't need accelerometers, we don't need impact hammers, we don't need hammers, modal shakers anymore. But that's not the case today. So today we still need EMA.
Yeah, we still need the EMA today to get a real response, but not just estimate, right?
Correct.
Okay. And the final question, why we should use the MMP solution for the model analysis?
Okay, thanks for this question. MMP Analyzer is a very powerful tool. It's also easy to operate.
Yes.
Many companies say they have easy to operate software, but we have indeed. So let's say you have wizards that guide you to a complete test setup before starting a measurement. So you are forced to go from one point, slide to the other. Analyzer is also very efficient in operation. You can drag and drop test results in a 2D or in a 3D waterfall diagram. Also worth to mention is that the experimental modal analysis can be done by a single operator. You don't need many people, just by a
just
single.
one people.
So we have audible noises where you can really listen, is it a good measurement or a bad measurement?
Okay.
Yeah, so reporting tools. We have up-to-date curve fit algorithms, yeah, in multi-degree of freedom analysis. Yeah, so we have time domain and frequency domain curve fitters up to date that will give you good results. We also have parameters to show you, is my measurement good enough? How can I rely on this measurement? Analyzer is upgradable, so for the customer who maybe has not the application today, but the application tomorrow, like vibration control or rotating machinery, or maybe he wants to go more in acoustic applications. So he already has a basis with analyzer and the M+p hardware, so he can really go in other applications in the future. Yeah. So
not only the model analysis, the M+p analyzer can offer the function like the rotating machine, the acoustic testing, and environmental testing.
Yes, so that is the advantage with the M+p solution, generally speaking.
Great. Okay, so we have the 5 questions, and thank you, Christian. Thank you.
Thank you very much.
Thank you.
Edward, thank you.
OK， 今天我们非常谢谢 Christian 来台湾，而且来跟我们参加这一次的这个回答哦。希望这几个问题的答案希望能够协助到大家。谢谢各位，拜拜。
拜拜。